Okay, the next piece of the puzzle for scheduling mathematics, the next piece of the introductory lesson, is to discuss the idea of precedence relationships between the tasks. There are restrictions on the order that we can complete our tasks. Like we said before, for example, if two of our tasks were to drywall the house and paint the house, we would have to do the drywall first, because if we don't do the drywall first, there's nothing to paint. So we would indicate this using what is called a precedence relationship. It's a type of symbol to indicate that D must precede, there's my spelling again, P. You must drywall before you paint, okay? You can't paint walls that aren't there. So when we have an overall project listed for us, it will have three columns. The first column will list the tasks. This is that Dream Home on Mars problem again. The second column will list the symbols and the processing times. And the third column will contain all of the precedence relationships. So if you look at that third column, you'll notice that the first thing it says there is AP has to happen before IF. In other words, if you, according to this problem, if you don't have a pad down, a foundation on Mars, you won't be able to install the floors. That obviously is extremely true. All right, so the reason that you need to have this information right away is this information actually tells you that when you're actually starting the schedule, which tasks are ready and which tasks are ineligible. So the way that we tell, and it's a very simple idea, is if we look at the tasks that are listed after the arrows, so all of these tasks, all of those tasks are ineligible. At the start of the project. Because all of those tasks have something that must happen before they happen. So if we were to go through our list over here and just quickly drop, just a dot of color on the ones that we've highlighted, IF is not ready, IW is not ready, IDPL, IPPU, HUIC, EU, FW, and PD. Those are the ones that we've highlighted. So those are the ones that start off in, remember we talked about the 4 stages, ineligible, ready, in execution, and complete. All of these are ineligible. Okay? Which means that these 4 tasks, AP, AF, AW, and AD, those are the tasks that are ready and that we could assign right away to a processor at the beginning of the task. So again, the precedence relationships serve 2 purposes. The first purpose is to tell us what order we have to do things in. And the second reason we have them is to be able to tell which tasks are ready at the start. One of the types of problems we do in this unit is we have to draw a graph, this is graph theory, a graph to represent the project. And in order to do that, we have to know what's ready at the beginning. So let's take a look at the graph for this particular task, Dream Home on Mars. Here is the graph for the Dream Home on Mars. This is called a directed graph or digraph. Okay, digraph's just a short way of saying directed. This is a digraph. If you notice, every single edge in this graph now has a direction, which means that a lot of the vocabulary we've previously discussed for graph theory is no longer going to work. And we are going to have to redefine some terms, alter some terms to fit digraphs specifically. So directed graph is the new type of graph theory that we're dealing with in this particular unit. That might be it for this video. Yes, it is. Okay. So in the next video, we'll discuss the vocabulary for directed graphs.